Welcome, I'm your teacher, Mr. Davenport, and in this lesson we're going to be looking at some velocity problems just for practice. We're going to read and identify the data and variables in the problems. We're going to learn how to set the problems up in 3 steps and carry the units through the problems. We're going to use dimensional analysis as necessary. And don't forget, you can download a hard copy of the problems simply by clicking right here. So go ahead and grab something to write with, grab something to write on, grab a calculator, and let's go ahead and look at some of these velocity problems. The first few problems on this paper just take us through some of the basic understandings that are necessary for understanding velocity and speed. So when we answer these, it's really important that you understand what these questions are talking about. For instance, the difference between distance and displacement is that displacement has a direction and distance does not. Why is it that displacement has a direction? Well, where does displacement comes from? Well, displacement comes from a change in position. So if you're located right here at point X and you change in position and move over here to point Y, that change in position represents your displacement, X. That displacement not only has a quantity, it might be 4 kilometers or 20 centimeters, but it also has a direction. You notice that I drew an arrowhead on this. That direction can be a compass direction, north, south, east, and west, or it can be represented as a relative direction such as up or down or left or right. Anyway, it's given a direction, and even if that direction is not stated, it is understood that any time you talk about displacement, you're talking about change in position, and it has a direction. Even if it isn't stated, it's understood. So in the second problem down here, it says the difference between speed and velocity is that speed is a scalar quantity and velocity is a vector quantity. Very important concept. Why is velocity a vector quantity? Velocity is a vector quantity because it's calculated not using distance, but it's calculated using displacement, and displacement has a direction. That's important. Velocity is a vector quantity because it's calculated using displacement, and displacement has a direction. Even if the direction isn't stated, it's understood. And when you talk about velocity, it's simply understood that it has a direction. The equation used to calculate speed is simply speed equals distance over time. It's actually distance over change in time, or simplified distance over time. But the equation used to calculate velocity is equal to change in position, or displacement, divided by time. And that idea of being calculated using displacement means that velocity itself has a direction, and therefore it's a vector quantity. And this equation is then velocity equals displacement divided by time. That's the equation we'll use whenever we calculate velocity. When we calculate speed, we'll use speed equals distance over time. When we calculate speed, we understand that it doesn't have a direction, and it's a scalar quantity. When we calculate velocity, because it's calculated using displacement, change in position, or displacement over time, it has a direction, and it is a vector quantity. In problem 7, we're asked to find the average speed of a car that travels 800.0 kilometers in 4.5 hours. It's a fairly simple problem, but there are some things that you have to remember. The first thing we're going to do is we're going to look at the problem and we're going to decide what information we're given in the problem. In this problem, we're asked to find the average speed. Well, average speed has a variable name. It is an S with a line over it. The line simply means average. And the S stands for speed. So what is the average speed of a car that travels 800 kilometers in 4.5 hours? Well, the kilometer that you see here is a distance. You notice that there's no direction given with it, and there's no direction implied. So this is going to be a distance. And obviously 4.5 hours, that's a unit of time. So in this problem, we're looking for average speed, we have a distance, 800 kilometers, and we have a time, 4.5 hours. So obviously now the equation we're going to use is average speed is equal to distance divided by time. And all of these problems that we're working here today are set up in 3 steps. The first step that you see here is to simply write down the equation, the proper equation that we're going to use. Average speed equals distance divided by time. The next step is to substitute the proper values and units of measurement into that problem. Substitute the variables for the actual numbers and units. So the distance, D, becomes 800.0 kilometers. 800.0 kilometers. And the time is 4.5 hours. That replaces the T. The next thing that we're going to do is we're going to look at the units. No units seem to cancel out here. So the kilometers and the hours will show up in our answer. And the answer is, when we divide this out, it becomes 177.8, and that's going to be kilometers per hour. Just like that. And it's an important thing to note that the kilometer shows up in the answer. It doesn't factor out. The hour unit shows up in the answer right there. And this division line that you see right here, that division line also shows up in the answer right there. So that's where that kilometers per hour comes from. And the answer, correct answer, is 177.8 kilometers per hour. And we haven't talked about significant digits, so we're not going to have to worry about it yet in this problem. That's for a later lesson. Problem 8 says, if a rocket travels at a speed of 2000.0 kilometers per hour, how far can it travel in 0.50 hours? So if we approach this problem the same way we did the last one, the first thing we're going to do is look at the problem, read it, and we're going to identify what information we have in the problem. And in this problem, it gives us a speed, that's S, of 2000.0 kilometers per hour, and it asks us how far can it travel. How far? That is a distance. How far can it travel in 0.50 hours? That 0.50 hours is a time. So we're looking for the distance this rocket can travel at this speed in this amount of time, 0.50 hours. Well, our original equation says that speed is equal to distance divided by time. And since we don't have to calculate speed and we're asked to calculate distance, we're going to have to rearrange this equation so we get a brand new equation that says D equals, because we're looking for distance. Well, one way that you can do this is to use some very simple algebra. We know that if we want to solve for D, that we have to get rid of the T on the right side of this equation. Well, the opposite of division is multiplication, so we can multiply by T. And whatever we do on the right-hand side of the equation, we have to do the same thing on the left side of the equation. So we have to multiply the speed times time over here. Well, the time right here factors out. So our new equation says distance equals speed times time. So there's our new equation. Distance equals speed times time. Now if you've watched any of the previous videos, you know that there is actually a different way to rearrange this equation to help you rearrange it. It's called the magic triangle, and it works like this. If we draw a triangle and then we divide it into 3 sections, and we understand that the horizontal line, just like in a fraction, means division, and the vertical line means multiplication, then we can put this equation into this triangle. Speed equals distance divided by time. Now remember that that horizontal line, like I just said, is division, and the vertical line means multiplication. So this says speed equals distance divided by time. And if we're looking for distance, right there, distance is equal to speed times time. Remember that that vertical line means multiplication. So distance equals speed times time. Distance equals speed times time, just like that. And so there's 2 ways, the algebraic way and the magic triangle way, to figure out what equation to use. And the equation we're going to use in this problem is distance equals speed times time. So distance, second step, remember, substitute the numbers and the units for the variables. Distance equals the speed, and that speed is 2000.0 kilometers per hour. And that is going to be multiplied by the time, t, and time is 0.50 hours. Well, the first thing that we notice here is that the process of dimensional analysis cancels out that unit hour. Why? Because you have an hour above a division line over here and one below a division line over here. Remember that this is actually, if you stop and think about it, 0.50 hours over 1. You wouldn't normally write it like that, but that's really what it means. And since this hour is above this division line and this one is below, then they're going to factor out. So when we look at this, the unit in the answer is going to be kilometers, which is certainly a unit of distance, and therefore there's a double check. We know that that's going to be the answer. So we multiply 2000.0 kilometers times 0.50 hours, and we get a distance of 1000 kilometers. And remember, the kilometer is the only unit that comes down, the hours factored out. And so our answer is 1000 kilometers. Problem 9. If a rocket travels at a speed of 2000.0 kilometers per hour, how long will it take the rocket to fly 4,564.87 meters? Well, let's go ahead and look at the information the problem gives us. If a rocket travels at a speed of 2000.0 kilometers per hour, that is the speed. How long will it take? Well, we're asked to find how long will it take, and how long will it take, that's going to be a time. How long will it take the rocket to fly 4,564.87 meters? That is a distance. Now we have a problem here, and that is that right here we have a distance given in meters, but the distance that's given up here in the speed is a kilometer, and those two have to match. You can't rearrange this equation to solve for how long will it take, the time, if we don't have matching distance units in both the speed and the given distance. So we're going to have to change this given distance into kilometers, or we have to change the speed 2000.0 kilometers per hour into meters per hour. Probably the easiest thing to do here is simply to convert 4,564.87 meters into kilometers, and we do it like this using dimensional analysis. Distance 4,564.87 meters, and we're going to multiply that by a conversion factor that will cancel meters and leave kilometers. And we can do that in one step. We know that if we have meters below this division line, it'll cancel out, and if we have kilometers above the division line, we can go there in one step. Then our answer will be in kilometers. So what is the true relationship between kilometers and meters? Well, 1 kilometer is equal to 1,000 meters. And so if we divide 4,564.87 meters by 1,000, the meters will cancel out, and it will give us 4.56487 kilometers. Just like that. So instead of using 4,564.87 meters in the problem, we're going to use this value, 4.56487 kilometers. So now we can set the problem up, and we're going to have to rearrange this and solve for time, and we're going to go ahead and use that magic triangle to do that. Now you can use some basic algebra, but since I showed you this in the last problem, we'll go ahead and use it. And the equation fits in here like this: speed equals distance divided by time. And we're trying to find the time right there. So time is equal to distance divided by speed. Time equals distance divided by speed. So we'll bring that equation over here. Time is equal to distance divided by speed. And now we can substitute the correct numbers and units of measurement into the problem to replace the variables. The distance is going to be 4.56487, and that's kilometers. And the time is going to be found by dividing that by the speed, and the speed is 2,000.0 kilometers per hour. And you can very quickly see here that kilometers, because it's above and below the division line, kilometers factors out, and that's going to leave the unit in the answer is a time unit, hours, which is just what we're looking for. Now we're going to solve the problem, and when we divide that out, it works out to 0.002, and that's hours. That unit hours comes down here. So our answer is 0.002 hours. Problems 10, 11, 12, and 13 refer to this particular scenario, which says Mo rides his bike directly east from his house to Jane's house, a distance of 3.0 kilometers. It takes him 0.5 hours to make the trip. Now in this story, we do have a time, we also have a distance, and we also have a direction. In the problem, it says, what is his average speed? We're looking for average speed. So how do we set this up? Well, very simply, we're going to use the speed equation in problem 10, which says that speed equals distance divided by time. And we're looking for average speed here. So I'm going to use that average line. So speed then is distance, and the distance is given as 3.0 kilometers. Just like that. And the time that's given in the problem is 0.5 hours. And so we divide 3 by 0.5, and the average speed works out to be 6 kilometers per hour. Just like that. Now we move down here to problem 11. What is Mo's average velocity? Now there is something different about velocity than speed. Remember that velocity is calculated with displacement, not distance, and displacement has a direction, and we have a direction here. It is east. And so to calculate the average velocity equals displacement divided by time. So our average velocity then is the displacement which is going to be 3 kilometers in the direction of east. And that's going to be divided by the time, and the time remains the same, 0.5 hours. So when we work out the average velocity here, we get an average velocity of 6 kilometers per hour, but it's east. And that illustrates the difference between speed and velocity. Next question says, question 12, what is Mo's total displacement? Well, his displacement when he reaches Jane's house is simply going to be equal to the distance, but it has a direction. It's going to be 3.0 kilometers, and that's going to be east. Why? Because when he reaches Jane's house, he is displaced 3.0 kilometers to the east of his origin, or his starting point. So now 13 here says, what is Mo's total displacement when he returned home? Well, when he returns home, he is no longer displaced from his origin. His home is his origin, and so when he returns home, his displacement is simply going to be 0, and that's because he is not displaced from his origin or his starting point. Our next two problems deal with the speed of sound. First problem here says sound can travel at 340 meters per second. How far can sound travel in 0.033 hours? Well, there's a couple of things to look at. First, let's go ahead and identify the information that we have in the problem and assign a variable to it. It says sound can travel at 340 meters per second, and of course meters per second, that's a speed, so we'll label that S for speed. How far can sound travel? Well, we're asking here how far can it travel. That's a distance, and of course we're given a time, 0.033 hours, so we'll label that T. It's always a good idea to go through the question, identify the information that you have, and label the variables in the question. It just helps you keep things organized. Next step, let's take a look and make sure that all of the units of measurement match. We have distance units, meters, right here. We have time units, seconds. And the unfortunate thing that we see here is that the time unit doesn't match. The time unit down here is an hour, the time unit here is a second, and we have to have those time units match. So how are we going to do this? Well, the easiest thing to do is going to be to change 0.033 hours and express that in seconds. Now we can do that like this. We simply use that process of dimensional analysis. The first step in dimensional analysis is to write down the given value and its unit. That means the unit and the value that you're starting with, which is 0.033 hours. And then we're going to multiply that by a conversion factor that will cancel hours and leave that time unit in the desired unit, and we want seconds. So seconds goes right here. So now the question is, 1 hour is equal to how many seconds? And if you've worked that out, or if you know it already, 1 hour is equal to 3,600 seconds. When we solve this problem, the hours are going to factor out. It's going to leave our answer in seconds. And so what we get when we work this out is 118.8 seconds. And we haven't talked about significant digits yet, so we're just going to leave that answer as it sits, 118.8 seconds. Now we have the time expressed in seconds, so we can go ahead and set the problem up. And we're looking for how far the sound wave can travel. And we're looking for distance. And we're starting out with the equation speed equals distance divided by time. Well, if we want to solve this for distance, we have to have a new equation that says d equals. So we have to get rid of the time on the right hand side of this equation. So we're going to multiply that by t, and that will cancel out time there. And of course, whatever we do on the right hand side of the equation, we have to do the same thing on the left side. So we're going to multiply the left side by t also. So our new equation says distance equals speed times time. So there's our new equation. Distance equals speed times time. Now it's just a matter of plugging in the numbers and plugging in the units and working this problem out in 3 steps. So distance equals the speed, 340 meters per second, times the time, and the time that we're going to use is right there, 118.8 seconds. And of course we notice the time unit cancels out, and so our answer works out to 40,392 meters. And you can easily see that when the seconds cancels out, it leaves a distance unit, and since we're looking for distance, that's a pretty good indication that we have this problem set up. So there's your answer. Alright, now problem 15. Again, this deals with sound. It says, how long would it take a sound to travel a distance of 0.022 kilometers? Well, the first thing we have to understand is that if it's talking about a sound, then we have a speed, and that speed is going to be 340 meters per second. The next thing we notice is that we're looking for how long, and how long means time. So we're looking for time. And we also have in this question, we have a distance, 0.022 kilometers, so we can label that D for distance. Now, if you notice, if you picked up on this, the distance unit down here, the kilometer, is not the same as the distance unit in the speed, the meter. So we're going to have to make those two match. And how do we make them match? Probably the easiest thing to do would be to change the 0.022 kilometers to meters using dimensional analysis. Now we could change the 340 meters per second into kilometers per second, or even kilometers per hour. We could actually do that, but we don't have to. What we need to do here is the easiest way possible. We're going to change 0.022 kilometers into meters. And again, to use dimensional analysis, the first thing we do is write down the given value and its unit. That's the starting point. That's the unit that we're moving from, and that's going to be 0.022 kilometers. And we're going to multiply that by a conversion factor that will cancel kilometers, so we're going to put it underneath this division line, and we're going to go to meters. That's our desired unit of measurement, meters. So what's the relationship between meters and kilometers? Well, 1,000 meters is equal to 1 kilometer. Now we know that kilometers will cancel out here, leaving only meters, and that's good. That's what we want. So we multiply 0.022 kilometers times 1,000 meters, and we get 22 meters. So 0.022 kilometers is the same as 22 meters, and that's going to be the distance we're going to use. So now what we have to do is set this problem up and find the time. If we're going to find the time, we have to rearrange that equation. Now we could use some basic algebra, or we can use that magic triangle. Now let's go ahead and use the magic triangle and see how it works here. We're going to draw a triangle just like that. We're going to put the speed equation in here properly, and speed is distance divided by, remember that horizontal line means divided, by time. So now if we're looking for the time, how do we find that? Well, time is equal to distance divided by speed, just like that. So here's our new equation. Time equals distance divided by speed. And so we're going to bring that equation over here. We're going to set the problem up, plug in the numbers, plug in the proper units, and determine the answer. First step, write the equation down. Time is distance divided by speed. Second step, plug in the proper quantities and units. The distance is 22 meters. The speed is 340 meters per second. So the time we get is going to be equal to 0.06 seconds. And there's our answer for question 15, 0.06 seconds. You'll notice here that the meters canceled out and only the time unit came down here. And if we notice that that's a time unit that is left over, then that is a pretty good indicator that we have this problem set up correctly, because the units canceled out correctly. Alright, question 16 says, Troll Guy jumps off from underneath a bridge and chases Moe's cat Fluffy down the road at 4 meters per second. 4 meters per second, that's obviously a speed. Suppose it takes Troll Guy 14 seconds, obviously a time, to catch up to Fluffy and give him a big hug. You didn't think that Troll Guy was going to eat that kitty, did you? He wouldn't do that. How far did Troll Guy have to run before he caught Fluffy? Well, how far? That's a distance. So we're looking for distance here. D. And since we're looking for distance, we're going to have to rearrange that speed equation and solve for distance. And we can use some simple algebra, or we can use that magic triangle. I'll set it up with a magic triangle just to help you get used to using it. We say speed is equal to distance divided by time, and we're trying to find distance, so distance equals speed times time. Just like that. And remember that that vertical line right here means multiplication. The horizontal line is division. So distance equals speed times time. We're going to bring this equation over here. Distance equals speed times time, just like that. So distance is equal to the speed. In this case, the speed is 4 meters per second. Times the time, 14.0 seconds. And we notice that the seconds are going to cancel out here. And the distance then is 4 times 14, and that's going to give us 56 meters. You'll notice that the meter is the only unit that comes down here. The seconds canceled out. And since we're looking for distance, then obviously we have this problem set up correctly because the units canceled out correctly. Alright, if Forrest can walk an average velocity of 3.0 meters per second, how long will it take Forrest to walk from New York City to California, a distance of 4,800 kilometers? Well, the first thing we notice is that we're looking for the time. How long will it take? That's the time. So we need an equation that says time equals. Obviously we're going to have to rearrange the speed or velocity equation. And since this says that we have an average velocity of 3.0 meters per second, we're going to assume that this is a velocity even if a direction isn't stated. We have to assume that it is either implied or understood because we're calling this a velocity in the problem. So we're going to use the velocity equation. And I guess if you look at this, he's moving from New York City to California. That actually gives us a direction of west because California is west of New York City. And that means that the distance of 4,800 kilometers is actually going to be a displacement x. Okay, so let's go ahead and set this up. We're first of all going to have to determine what our equation is, and we're going to use that magic triangle over here. We'll set this up and we'll put the velocity equation into it, and we know that velocity is displacement divided by time. Remember that the horizontal line here is division and the vertical line is multiplication. So velocity is displacement divided by time, and that means that the time is going to be displacement divided by velocity. So time equals displacement divided by velocity, and that's the equation we'll bring over here and use. Is time equals displacement divided by velocity. Now we just have to substitute some numbers, some values. Well, we have a problem. If you look at this, the distance unit or the displacement unit right here is kilometers, but the displacement or distance unit up here is meters, so we have to make them match. How do we do that? Well, we use dimensional analysis. And again, the easiest thing for us to do is simply change 4,800 kilometers into meters. We're going to express this in meters. So we can use dimensional analysis. 4,800 kilometers. We're going to multiply that by a conversion factor that will cancel kilometers and leave meters, our desired unit. And we know that 1 kilometer is equal to 1,000 meters. So when we multiply 4,800 kilometers times 1,000 meters per kilometer, kilometers factors out, and we're going to move the decimal point here. We're going to move it 3 places to the right, and this becomes 48. There's the 2 zeros, original 2 zeros. Now we're going to add 3 more, and that's going to be meters. So this actually becomes 4,800,000 meters. And this is a perfect example of a time when we can use scientific notation. If we move this decimal point 1, 2, 3, 4, 5, 6 places to the left, this becomes 4.8 times 10 to the 6th meters, and that's what we'll use for our displacement. So now let's go ahead and set the problem up. We have T equals displacement over velocity, and that then becomes the displacement, which is 4.8 times 10 to the 6th meters over the velocity, and the velocity is 3.0 meters per second. And you can see here the meters factor out, and because of that it leaves seconds in our answer, and a second is a time unit, so that's a pretty good indication that we have this problem set up correctly. And if we work this out, it works out to 1.6 times 10 to the 6th seconds. That's 1.6 times 10 to the 6th seconds, and there is our answer. 1.6 times 10 to the 6th seconds. Now if we wanted to, we could convert that to hours. If we wanted to, we could use dimensional analysis. We could convert that to days or even years if we wanted to. But it doesn't ask us to do that, so we're just going to leave it with 1.6 times 10 to the 6th seconds. Alright, a car travels at 55 kilometers per hour west for 4.5 hours. What will be the displacement of the car after this time? Well, we're starting with the velocity equation. V equals displacement over time, and we're rearranging that to solve for displacement. It works like this. We need to get rid of the time, so we multiply that out. We have to multiply the time on this side, and so our new equation says displacement equals velocity times time, just like that. If we plug the proper numbers and units in here, the velocity is 55 kilometers per hour west. Remember, we're dealing with a velocity, so it does have in this case a given direction. 55 kilometers per hour west. And we're going to multiply that by the time, and the time is 4.5 hours. So that gives us a displacement of 247.5, and that's going to be kilometers west. Now remember, that displacement has to have a direction. That's what makes it a displacement. And you notice here also, let me just point this out, that the hours factored out, so the kilometer is the only displacement unit that comes down here to the answer. So our derived answer is 247.5 kilometers west, and that is a displacement. Alright, the next problem down here says, look at the picture below. It is 3 kilometers from Mo's house to Mary's house. that would be this line right here, 3 kilometers from Mo's house to Mary's house. It is 1.5 kilometers from Mary's house to Alice's restaurant. 1.5 kilometers from Mary's house to Alice's restaurant. If Mo drives 3 kilometers east to Mary's and then 1.5 kilometers west to the restaurant, he has traveled a distance of, and remember, distance is the total length of the path traveled, so that would be 3 kilometers plus 1.5 kilometers. That means the distance would be 4.5 kilometers. But his displacement is, watch this, from the origin to the final point in his travels, that is his displacement. The displacement, if you recall, is the distance and direction between the starting point and ending point. In other words, how far at the end of his trip is Mo displaced from his origin, which is his house. So his displacement at the end of this trip is going to be 1.5 kilometers, and that's going to be east of his origin. So the E stands for east. So the displacement is 1.5 kilometers east. All right, hopefully these problems helped you understand how to use that velocity equation, how to use that speed equation, and we can take this to the next level and we can go on and talk about acceleration. So go back through the video, study it, and then when you're ready, we'll go on to the next video, which deals with solving acceleration problems.